Okay, so after the last lesson, we finally got to use the sensor for the first time. We used the light sensor in our emergency bot program to detect the light levels in a room and then calculate an average and a threshold that allowed us to teach the mBot how to react once the light levels went under a certain level. So for this next lesson called Jazzy mBot 2, the comeback, we're going to use the ultrasonic sensor, which is actually one of the most useful sensors the mBot has, to teach the mBot how to play notes depending on the distance from the mBot. Okay, so let's take a look. So now that we know a little bit about how sensors work, we're going to use a new one called the ultrasonic sensor, which is actually one of the most useful sensors we have because it allows us to determine if there is an object in front of the mBot. And once we can collect that information, we can teach it to do something. If you are wondering how this works, if you played around a little bit with your mBot, you can see this piece right in the front of it. It looks like a pair of eyes. What they do actually is that one of them sends an ultrasonic signal that you cannot actually listen because it's not you humans cannot listen to that signal, but it sends it and then the other eye receives it. And the way it works is that it measures the time that it takes for the signal to bounce and then come back, and by calculating using the time that it has, it can calculate the distance of an object ahead. So it works very similar to submarine sonar, if you're wondering how that works. So for this program, we're actually going to have only four objectives. The first one is that the mBot is going to detect objects ahead, and it's going to play a tone depending on if the object ahead it's in a range between 15 and 50 centimeters. If the object is out of this range, then it's going to stop playing anything, and it's going to play only an octave that's divided equally over the space of our range, which is 15 and 50 centimeters. And lastly, it's that the highest note will be played at 15 centimeters and the lowest one will be played at 50. Okay, so the analysis for this lesson, it's actually a little bit more involved in the math, but nothing too crazy. We have to determine first distance, and then using that information, we have to calculate the intervals at which our notes are going to be played. So I actually think that the process of explaining how this works is a little bit complicated unless you see it with an example. So I'm actually just going to take this part right here. If you're reading this on the website, what it says is that, for example, let's say we set up our mBot to use the ultrasonic sensor and it returns a value of 15.72 centimeters. So that's the value that we're going to receive. And the process that we're going to go in this with this number to calculate the note that it has to play is that we're going to use the mod operator. The mod operator, in case you've never used it before, since this is a course for beginner programmers, it's an operation that returns the remainder of a division. So if you have, for example, 16 and you use the mod operator, if you divide by 5, for example, using the mod operator, the solution it's actually 3. But if you multiply 5 times 3, that's 15. So you have a remainder of 1. The mod operator returns you that value. In this case, we're going to use it to convert our numbers into integers, which then can be used to calculate the note. So for instance, in this case, we have the 15.72. We're going to use this. So 15.72 divided by mod 5 gives you back a value of 0.72, which is right here, which then we're going to subtract from the original value, and that gives us 15, which then if we're going to have our notes and spaced equally over a range which is 15 to 50, allows us to calculate what note it's going to be. So if we're going to have from C to C, we can divide a range which is 35 by 7, and that gives us 5. So each node is going to receive a space of 5 centimeters to be played. So for instance, if the value returned is between 15 and 20, it's going to play C. If it's between 20 and 25, it's going to play D, and that's going to happen with every other node in an octave. So now that we have taken a look into that, we can actually take a look real quick to the flowchart. If you see here, we're going to begin as usual with our start block. Now I'm going to make a quick introduction to this type of block that we're going to put here. I just called it initialize variables. Even though that's all it says, there's so much stuff going on in this section of the code because much of the programs that we're going to be doing from now on involve defining some variables that we're going to use in our programs. But for simplicity and to make this flowchart easier to read, I'm just going to summarize everything that's going to happen here in initialize variables, but don't worry because we're going to take a look to that more into detail once we start coding. So moving on from this, as you can see here, we enter infinite loop. How do you know it's an infinite loop? It's because the possible outcomes from the last blocks that you can find here, they all return to a certain point inside this loop. So in this case, what is going to happen once we have initialized our variables is that we're going to use the ultrasonic sensor to read a value, the range that it's detecting from the object ahead, and then we're going to make a decision based on that value. As you can see, we're using this block right here, which we use to define a decision that we have to make in our program. If the value that we read from the ultrasonic sensor it's not within our range, 15 to 50 centimeters, we're going to stop playing a tone. The mBot is not going to do anything, and it's just gonna stay there. If, on the other hand, the value that's returned to us it's within the range, we're going to calculate the note that we have to play. Once again, this block right here has more stuff going on. To calculate the note that we have to play, we have to do a lot of math, and then we're going to play that note, and this is going to happen continuously, and this decision making is going to go continuously until you either turn your mBot off or the mBot runs out of battery. So now that we have taken a look into the design, let's real quick start coding. So first of all, we have to open, of course, our program as usual. We're going to be using mblock again. As usual, just say no to that in case it gives you that. And it's always a good idea to go to Arduino mode because then you can see what's going on over here. And we can only use the blocks that are compatible with the mBot, so it reduces your options significantly, makes things a little bit easier. Okay, as usual, remember our first block we have to use is this one called mBot program. Nothing happens. We're going to be defining some functions, some blocks, but they won't run anything unless they are under the mBot program block. What we're going to do now is we have to set up a bunch of variables like we do for the nodes, like we did in our last program. So bear with me because it's a little bit time consuming, but as you know, it is necessary. And don't worry about the values necessary for the nodes. I'll be giving you that in a second. I hope actually I'll remember a little bit of what we did in our lesson for the JazzyBot, since if you remember, to play a note we have to use the frequency of that note. You don't need to memorize that. You can just Google it, or I'm going to give you the ones you need for this. But if you want to play something else, of course, you can just Google it real quick. What's the frequency of a certain note? And you can use that. If you know a little bit about music, you can use find for the written music of that. B4, C5. Okay, and well, these are all the notes that we're going to use. But on top of that, we also need a couple more variables that we're going to call minimum range and maximum range. I just have to make a double check later to make sure that I actually set up all the variables that I need. Okay, and as you remember from the flowchart, we're going to call this block initialize, and this is going to be a block. We're just going to call it initialize, and under here we're going to set up all the variables we need. So first set we're gonna go in order. So C4, duplicate, paste. You can do that. I mean, you could of course drag it again, but if you remember and you want to do this a little bit quicker, you can duplicate from the top, and that's going to duplicate everything that's underneath the block you selected. In this case, E4, then F4. We may need to duplicate even 4. Then it's gonna go G4, A4, B4, and C5. And lastly, we're going to need 3 more for our minimum range and maximum range. And lastly, our interval. Okay, so now for the values of the frequencies for the notes. C4 is 262, D4 is 294, E4 is 330, F4 is 349, G4 is 392, A4 is 440, B4 is 494, 523 goes for C5. As you remember, our minimum range is 15. And even though I told you at the beginning of this program that our maximum range is going to be 50, we're going to add a little bit of caution at the end to make sure that this note is played. So in this case, we're just going to add 8 centimeters just to make sure this note is played. And as you remember, our interval was 5. So once again, this code is not going to run unless you take this block from here and put it under your mBot program. Okay, so once you have that, okay, let's go take a look again at our flowchart. We're gonna go into an infinite loop since all of our options are going back to the same point. So if you remember to use a while loop of loop that it's gonna be running forever. In this case, indefinitely, we're going to use this and under our control section that says forever. And what we have to do now, we're gonna need another more variable. And we're gonna call this one range. Yes, so we're going to set range to something. Set range, in this case, we're gonna go mBlock. The mBlock interface makes things really easy for us. If you go under the robot section, you can basically use all the, well, find the block that's used for your every sensor the mBot has. So in this case, if we want to use the ultrasonic sensor, we have to find the block that says ultrasonic sensor. I think it's almost at the bottom. Okay, there you go, right there. So ultrasonic sensor port 3. Just remember, if you set up your mBot the way it's instructed with the manual that comes with your mBot, then it's and port 3. If you connected it somewhere else, just make sure this value is set up for the correct thing. And okay, so let's move on. Now we're going to go to the control section and we're going to use this if then block because we're going to make a decision. First of all, this might get a little bit messy, but bear with me. So we're going to use, first of all, this logical comparisons. This one's called AND. This comparison, in case you've never used an AND operator before, it tells you that this is going to be true if this block that says if returns true, then it runs whatever code is underneath. But if it's not true, then it skips it. So in this case, it will be true only if 2 conditions are met. And that's only if both conditions are met. So if this condition that we're going to put here is true and this one is true, then it's going to run. But if one of them it's not true, then it's going to skip all the code that we're going to write underneath here. So that's how an AND operator works. And then we're going to negate something. So yeah, remember I told you this was going to be a little bit messy. I'm actually going to close a little bit so you can see what is going on right here. So then what we're going to do is use this comparison right here. One for that and one the other way. There you go. So that's what it looks like. This comparison, it's less than, the other one, it's more than. As you can see, there's two things in one on each side. One thing on each side, so two in total. How you read this is if this thing on the left side is less than this thing on the right side, it's going to return true. Same thing here. If this thing is bigger than your thing on the right, so it's the contrary. In this case, what we have to use to make our decision, if you remember again, this is the part that we're writing, okay? This decision making. So what we have to do is write range, your variable that was set up above, and on the other side we're going to put minimum range, and that one it's right here. Okay, so we're going to do something very similar on the other side. Let me just put it down again so I can read again. Okay, maximum range on the other one. Oops, there you go. Okay, so that's what it looks like. Once again, it looks a little bit messy, but let me explain. So once you're reading your value from the ultrasonic sensor, what you're going to do is this decision right here. I'll rewrote right there, it's for that decision. What it says is, if your range is not less than the minimum range, and your range is not bigger than your maximum range. So in last words, that means if your range is between 15 and 50 centimeters, then you're going to do something. And only if those two conditions are true. If your range got on this value is larger than 50 or smaller than 15, then don't do anything. Skip all that. What we're going to do is we're going to set this part right here. It's called normalizing. Let's just skip this part for now since it's not important right now for learning the code part of this project. So what we're going to do is this, just range minus the minimum range. Okay, and then set this range to, oh, actually, all right, so that it's this, if I remember correctly. Set range, we're going to use a division. We're going to divide by the interval. Bear with me a little bit more. Once again, this might get a little bit messy, but it's quite all right. Then a subtraction right here. And lastly, a mod operator. That's gonna go here. Okay. So your range right here. Yes, on that section right there between the mod, and your interval on the other side. And lastly, your range. There you go. Make sure you put it in the correct section, otherwise it makes something really weird. I'm not gonna do it right now because it's all okay now. Okay, so this part right here, in case you're wondering what all that gibberish is, it's this operation basically. What you do is first you normalize it, and then you calculate this. So what happens first, it's we're going by levels, of course. Take your range, use the mod operator with the interval, which if you remember, I think we set it up here correctly, yes, to 5. Then it subtracts that remainder from the original range that converts your value into an integer, and then you divide it by the interval, and that's going to give you your value that we are going to use to determine the note that we're playing. So now that we actually have these two parts correct, we're going to need to create another block We're going to call this block play, and it's actually going to take an argument. That's what we call it, and this function. Okay. Options. There you go. It wasn't letting me do that, but we're going to call this note. Okay, there you go. Let me bring this a little down. Okay. So play. All right. We're gonna need once again another variable, this time called tone. It is also always, I mean, we could have called this something else. Just try to keep track of everything, because if you're dealing with multiple variables, things can get messy. But in this case, we're going to start this variable named tone to a known value, which is 0. So initially, this value is going to be 0. Then what we're going to do, it's a bunch of decisions using the if-then block. And what we're going to do here, it's a comparison again, using this. Oh, not this one. That's the multiplication. It's this one. It's equal. So what you're going to compare is this value. It's also important to remember. Well, I'm going to explain that a little bit, because what we're going to do actually is that we're going to use this block right here called play, and we're going to send. I don't have a value for that. Let me call it something else. I don't want to call it note or tone, because that's going to make things confusing. So let's just call it musical note. I know it's very similar, but it's what's necessary. So what we're going to do is, I didn't do that here, but musical note, it's going to be that. And then we're going to send that value to there. So once you make sure that your the value you got from the ultrasonic sensor is within range, and you've processed it, you're going to send it to this function right here. This value that you sent takes the place right here. So this value, this function runs this code, but the note that you sent, it's the one that's being interpreted here. So it's it might be a little bit hard to grasp that concept of what's happening here, but that's basically what we're going to do. So in this case, we're sending this value to this function. The function receives it here, and it names it note. So that's what's happening. In this case, what we're going to do is set it to 1. Then you're going to set tone to note C4 for the first one. Yep, that's basically what's going to happen. And this is going to happen, it's going to make this decision for every single node that we've defined. So this becomes a little repetitive, but once again, you can do this to try to make things a little bit less repetitive. Just make sure you, once again, you keep track of everything, because even by doing this, sometimes it has happened to me that I do this and then I forget to change, for example, these values, and then my program doesn't work, and I'm wondering why, and that's because I didn't change all the values, and you also have to change this one. So 2, 3, 4, and actually let me zoom out, because this is making things a little bit more complicated. 4, 5, 6, that didn't change, 6, 7, 8. Okay, now that's C4, D4, E4. Make sure you delete this ones. Oh, I forgot. Yeah, you could do that. F4, G4, A4, B4, C5. Yeah, so that's what's going to happen right here. Once again, let's go through the process. Once you receive the value from the ultrasonic sensor, it's going to Make sure that your value is within range. If it is, it's going to process it, normalize it, run all this mathematical operation, and then send that value to here. What's going on here if your value is, for example, 40, which is within range? You do this 40 over 5. I mean, the mod operator is not going to return anything because the mod operator is going to return 0. 40 you can divide over 5 exactly, so there's no remainder. I think it's 8. 8 times 5, 40. Yeah. Yeah. Okay. It's going to go here. Okay, and so then what's going to happen right here? Lastly, we have to add one more conditional that says if then. Okay, so we're going to do one more thing here that's not, and this, once again, things might get a little messy. We're going to use the tone, and for here just set it up to 0. So remember, we begin this the tone to be a value, a known value, which is 0. That's what's going to happen. If the value that we received is anything like 1, 2, 3, 4, 5, it's going to set it up to a certain note. But if not, it's going to set it up to 0. And what it's going to do, if you remember how we use the integrated speaker, is we use this block that says play tone on note. In this case, it's going to play to whatever was set up for the tone, and it's going to play it, let's say, for half. Actually, I don't think this matters too much because it's running on a infinite loop, so that's going to be just playing infinitely. And yeah, so this is what your code ends up looking like. Let me drag this a little lower. If I'm correctly, this code should work now. And what happens now is that you have to upload your program to your mBot, because remember, at the end of the day, the most important part is uploading it to your mBot and making sure it works. Okay, so for the testing part of this project, I grabbed this. I think they're napkins. But all you have to do now is turn your mBot, and it's going to start running your program immediately. There you go. That's what it looks like at this distance. If I get it closer, now it's too close. There you go. Just make sure it works. If it's not working, you can download the code from GitHub, or you can watch the video again, and just make sure you learn how to use the ultrasonic sensor, because we're going to be using it for future programs.